All right. Thank you all again, and good morning. My name is Dhaval. I'm the product manager with QNAP, and thank you all for joining our workshop. With me is Daniel.
Hello, I'm the technical sales lead here.
All right, so today we'll be going over, today is our workshop for this quarter. We are going over our virtualization storage solution that QNAP has from VMware and Hyper-V. We'll be more focusing on how to set up your QNAP for best performance as well as best setup for your virtualization storage. Let's look at today's agenda. So we'll be learning about the best practices to configure your QNAP NAS storage to achieve best performance for your virtualization environment. We'll be setting up or we'll be going over best practices configuring the networking as well as the data store for on VMware for best performance and reliability. We'll have a Q&A session after that for a few minutes, and then we can continue on with snapshot replication with snapshot agent, as well as know how to add redundancy to your VMware setup, as well as learning about and we'll then end with Hyper Data Protector, our new application that focuses on license-free VMware backup or VM backup that is available from QNAP. And then we can end with another Q&A session. So now you guys can always ask questions in the Q&A section if you wanted to have some information or clarity during the workshop, or you can wait for Q&A sessions that we have between the workshops as well as towards the end. You can feel free to unmute yourself to ask further questions, and we can have some conversations back and forth as well. And then we'll leave our email addresses as well if you wanted to reach out to us after the workshop as well. This is all recorded, by the way, so you can always we'll send you a link after this. You can always play back, and this will be posted on our YouTube channel called QNAP College in the workshop section. So if you missed something, I understand this is a longer format of the workshop, so you may not be available for the whole workshop, or if you have joined in late and you wanted to go back and see what we have discussed before, you can always look at our YouTube channel to see what we have discussed before. So with that in mind, let's get started. So first we'll talk about how best practices to configure QNAP NAS storage for to achieve best performance on your virtualization platform. So Daniel, you want to get this started?
Sure.
I'm going to stop sharing my screen.
So for part one, learn about best practices to configure your NAS storage system to achieve best performance in a virtualization environment. So first of all, in virtualization, most of the time, what's needed is high IOPS. Now, it, of course, depends on what you do with the VM. There do exist VM applications where you care more about throughput, but most of the time it's about IOPS. And so do you want to have HDD storage or SSD storage? SSDs tend to have multiple orders of magnitude more IOPS than HDDs, but HDDs are cheaper. So it's about balancing performance and price, but IOPS is usually the most important for performance. And we have NAS for HDD storage, NAS for SATA SSD storage, and NAS even higher IOPS for NVMe storage. NVMe SSDs can have significantly higher IOPS than SATA SSDs. Something else to consider for your storage is, do you want all your VMs on one NAS or not? So if you have, say, 20 VMs, we're going to suggest probably one LUN per VM. So when you have 20 LUNs, you're free to put 20 LUNs on one NAS, split 20 LUNs on two NAS, split 20 LUNs on four NAS. It's up to you. But if it's all on one NAS, then all those LUNs share the performance of one NAS. If you have two NAS, now you have two NAS worth of performance. You have four NAS, you have four NAS worth of performance. You need at least one LUN on each NAS, but you can split up many LUNs on as many NAS as you want, and more NAS generally do give more performance. So it really depends on the level of performance you need for your use case, how many NAS you want to have, HDD, SSD storage. Also, when we talk about HDD storage, because some people do use the spinning HDDs, we do support SSD cache. But I would also like to mention that we do also have ARC RAM cache on our QUTS Hero NAS. So for some cases, it might be best to use SSD cache, but for some cases, it might be best just to let the RAM cache do its job. And for SATA SSD storage, I will not suggest SSD cache, but even for SATA SSD storage, the RAM cache can still be helpful. Other thing I would mention is block size, probably 32 kilobytes for the block size with VMware. But if you were to use like Hyper-V, it'd be 64. We also support ZIL. So maybe I should actually demonstrate this now. So let's actually go on the NAS. So let's go. First of all, I'm going to show just from the start, go to storage and snapshots. Then click storage/snapshots, because before you can make iSCSI Lens, you have to make a storage pool, new storage pool. So select your drives. So if I were to select all 4 drives, I would have an option of, RAID 0, 5, 6, 10. But I don't want to select all the drives now because I want to at least show you how you could make cache. So I'm going to leave 2 drives left over. I'm going to do RAID 1.
Now, before we continue, now if you have a larger unit that is anything like a 16 bay or 24 bay unit, you're limited to, I think, 16 bays on one RAID. So I think, yeah, if I remember correctly, 16 bays per RAID group. So let's say if you buy a 3087, which is our 24 bay, 24 HDD and 6 SSD bay units, then at that point you will select 6 bays for RAID 5 or RAID 6. And then you add another 12 bay into that for RAID 60. So that's again, that is also another option as well. If you have a 16 bay unit, maybe you probably go 8 and 8. We always recommend to have the same size, same number of disks on each RAID group. So that's also another option. But the maximum number of disks on a single RAID group is about 16. So that's where you can decide if you want to go with RAID 5, RAID 6, RAID 60 as well.
And so something that a lot of people get confused about this, though, is the 16 drive RAID group limit does not apply to RAID 50 or RAID 60 or RAID 10, because all those RAIDs 50, 60, 10 are made out of smaller RAID groups. So if you make like a RAID 60, that can be as many drives as you want, but since a RAID 60 is made out of RAID 6s, each RAID 6 cannot be more than 16 drives, but you can have as many RAID 6s in your RAID 60 as you want. There's no limit there. So if you have your 24 bay NAS, no problem doing 24 drives RAID 60. That's usually what I suggest in a 24 bay NAS. And so yeah, on a 16 bay NAS, you might likely do a RAID 60, which is made out of 2 like 8 drive RAID 6 groups. As a general rule, if you have more smaller RAID groups, you get better IOPS. But of course, if you have fewer larger RAID groups, you get a little more storage. But because this is VMware, IOPS is usually the primary concern. You likely want to configure for IOPS. So that could be like a 16 bay, that could be RAID 10, but it could also be RAID 60. You technically could do one large RAID 6, but the IOPS may not be as good with one large RAID 6. So I'll make my RAID 1 pool, and I'm just going to make it. And so over here it has optimized pool performance. What this is because we do not force proprietary drives. There could be a wide variety of drives that you could use in your pool. And we want to configure the parameters of the pool to work best with the parameters of the drive. And since there's a wide variety of drives you might use, we can scan the drives. And having scanned the drives, we can then optimize the pool for those drives to get a little better performance. Over here, pool over provisioning. When storage pools get more than 90% full, they tend to slow down. And also keep in mind, if you use thick provisioning, it pre-allocates the pool size. So if you were to have no over provisioning, make like a thickly provisioned folder that's like 99% the size of the pool, you would have like almost no free space in your pool. And that can actually lower performance. So we suggest 10% pool over provisioning, and it ensures that you got good performance all the way. And also, if you use thick provisioning, you especially really need this over provisioning. But most of the time I suggest thin anyway. It just depends on the use case. Guaranteed snapshot space could be changed later. So this could be changed later as well, but guaranteed snapshot space really just depends on how much you want to have for snapshots. But keep in mind, you don't have to guarantee any space to use snapshots. You could have no guaranteed space. As long as there's free space on the pool, you can take snapshots. Guaranteed space, reserve space on the pool, it does not allow you to put anything else there. Where if you have non-guaranteed space, you can still use it for snapshots, but it just won't stop you from using that space for something else. So this might take a little while since we do have to check the parameters of the drives to optimize the parameters of the pool to the parameters of the drives. So maybe rather than just have you just wait while it does this, maybe we should talk about just some of the other things we have. So let's talk about cache acceleration. I'm not going to actually set it up because first of all, I do not suggest SSD cache applied to SSD storage. And on this unit, it's all SSDs. So I'm not going to do the cache, but I'll talk about how to set up the cache. But cache should typically only be applied to HDD storage. And so I can't go much farther now because it's making the pool.
Well, in the meantime, we can show this iSCSI creating the LUN.
Okay, yeah. So
we can go on the TPS 574.
Yeah, so let's go on the 574, yeah, and talk about how to make a LUN. That's a good idea.
Now, to create an iSCSI LUN, again, it's back into storage and snapshots, and there's an iSCSI section right there to be able to set up iSCSI storage.
So I'm going to create a block-based LUN. I guess I can call it LUN1, and you can do thin or thick provisioning. If you do thin, you are free to set it to the size of the pool capacity, but you also might want to limit how much space a single LUN for a single VM could take. So that's up to you, but it allocates space as it's actually used. So you can have a large LUN and it won't take that much space on your NAS as long as the LUN's not full, because I'm using thin provisioning. Alternatively, you could use thick. So block size, you see 64K is for Hyper-V, but we're using VMware, so let's go to 32. And we have encryption, but I'm not going to do that right now.
So now with QTS Hero, you can do encryption on iSCSI LUN as well. So there were a lot of requests were coming in for iSCSI encryption. We have that for QTS Hero. We'll have that soon for QTS platform as well. But QTS Hero does have the encryption as well. So if you do want to encrypt your LUN, you can encrypt it when creating the iSCSI LUN. And then when you reboot it, just have to remember that it will lock the LUN. So VMware may not be able to see the data in there.
So now I'm going to map it to an iSCSI target. An iSCSI target is what allows it to connect to a VMware server. And I could choose a target that I've already made, or I could also just make a target right now. So I'm just going to, why don't I just actually make a new target?
Yeah, just sure.
So you, of course, can do chat, but I'm going to just do no chat. And next. I'm going to choose the adapter it uses. Adapter 2 is actually connected, so I better choose that one. And I'm going to cancel here because I already made a LUN. And so here's my unmapped LUN that I made already. And action. Edit LUN mapping. Map to an iSCSI target. So now let's see where the creation of my pool is at. So from here, let's see what I can also show. So from here, I can also show cache accelerations since I'm making the pool on the other NAS.
We have free disk on that though.
So yeah, we may not have the free disk to actually do it, but here's at least the option. So create an SSD cache for read and write, or an SSD cache for read or write. When we say write, we mean ZIL. And so, because this is a hero unit, on QTS Hero, ZIL is not standard write cache. And I think that's a good thing because standard write cache actually adds some risk to your data. Like if you lose power while you're flushing data from standard write cache to your LUN or whatever, you can, there could be risk of corruption, but this is ZIL. So ZIL is a little bit different. What ZIL does is it really only helps with synchronous writes. For asynchronous writes, we have a write coalescing feature. Many small writes are held in the RAM and coalesced into larger chunks and written more sequentially to the drives to have faster write performance through write coalescing. And that works well for asynchronous writes. But synchronous writes work a little bit different. You write a block to the NAS, and you are not allowed to start writing the second block till the first block goes to persistent storage. The way ZIL works is ZIL will function as that persistent storage. It's lower latency than the hard drives. So you write a block to the RAM, it goes from the RAM to the ZIL, and it's considered persistent storage. Write the next block to the RAM, then writes to the ZIL, next block to the RAM, then to the ZIL. And once you've accumulated enough blocks in the RAM, then it coalesces the blocks to the RAM. It coalesces the blocks that are in the RAM, and then it writes it sequentially to the drives. Once you've written sequentially to the drives, you can then delete it from the ZIL. So the ZIL just kind of holds those blocks temporarily in case the NAS loses power, because RAM is not persistent. If the NAS were to lose power, it would lose it in the RAM, but the ZIL keeps a copy of whatever is in the RAM. So if the NAS loses power, nothing's lost, and it allows the write coalescing feature to keep working and protect your data. So ZIL allows you to use the write coalescing feature more effectively, even when you need to do synchronous writes. When we do talk about iSCSI, typically a portion of those writes are synchronous and a portion are asynchronous. If you map NFS, NFS by default is synchronous, so ZIL would help us, especially on NFS, but helps some on iSCSI as well. So that's what we call write cache here. We're talking about ZIL. So you can have the same SSDs be both read and write, or they can be just read or just ZIL. So I don't really have the free SSD space, but if I had the free SSD space, I'd do it here. Let's see where we are on the optimization. We're getting close for optimizing the storage pool on the other NAS. So maybe now is a good time to actually ask some questions. Let's see, do we have any questions so far?
Yeah, no questions there. So again, if you have any questions, just you can post it on the Q&A section. You can also unmute yourself to ask questions as well. We also have units that come with hybrid setup as well. So or you can create your own hybrid setup where you can have an all-flash unit that is all SSDs, and then you can add expansions with all HDD as well. In that scenario, you can create 2 data stores or 2 VMware iSCSI LUNs, or you can have multiple. So as Daniel mentioned before, it's recommended to have a VMware. Sorry, it's best to have a data store for, not data store, basically an iSCSI LUN, or actually data store as well for each VM that you're going to be using, and also its own initiator as well. So let me take over the screen so you can show. So let's sorry about that. Okay. Now, so as Daniel was showing, to create an iSCSI, you just go to storage, a snapshot, go to iSCSI and Fiber Channel. Now, let's say if you want to create a new VM, it's recommended to have its own, the VM should on the QNAP. So when you're creating a VM, it's best to have its own, instead of sharing a one large LUN with its own initiator, or having one initiator having a large LUN. Let's say if you have, let's say you plan to have about 5 VMs into a VMware, and you want to give a LUN for that VM. So instead of create, and then maybe it's 5 terabyte, it's 1 terabyte per VM that you want to give the storage space, right? So instead of creating a 5 terabyte single LUN with its own initiator, and give it and then sectioning it out through VMware by cutting it to 5 terabytes on the same exact LUN, it's best practice to create a separate iSCSI initiator and then separate iSCSI LUNs inside the QNAP. So that's best practice. It will give you better performance as well, because when all the VMs are running and it's sending IO requests, it's not sharing the single initiator. It's actually going through its own initiator. So the processor of the QNAP can be able to handle that much better, because it's able to use all the information available from all the different initiators. So let's, for example, if you want to have a new VM, so what you want to do is first come here to the QNAP, just create its own initiator, say VM1, and then hit I guess already have it, so something you can name. This is a random that you want to name. You can also do advanced settings, so you want to have data digest or header digest as well, but that adds more more overhead to your networking as well. But you can do that as well. We have CHAP authentication if you want to do CHAP, and you can also do mutual CHAP as well, where both can communicate with each other with its own authentication method, and then be able to usually not a lot of people use CHAP, so you can hit next. Now if you have a direct connection to the VMware, where there's there's a direct connection, 10G connection coming from VMware to your QNAP, because QNAP can also have multiple networking as well. Most of our QNAP, especially people who are using for VMware, they usually have a 10G card that's built in. That's the best advantage of QNAP, right? A lot of devices that come with built-in 10G port, rather than having to purchase additional cards, at least on a mid and higher end units. So so in the QNAP, you probably have one management port that is connected to the 2.5G or 1G port on the NAS, as well as the 10G port is connected directly to VMware. In this case, you can since the QNAP has multiple 10G ports, you can use it for multi-path MPIO, or if you want to just control yourself, you can actually share one 10G port to have like certain VMs, and the other 10G port will have its own VM. So here you can actually ask, or you can actually ask the QNAP for this iSCSI, use this particular 10G port rather than, and then so in this way the QNAP is not, or you don't have to guess what IP address. You just have to enter, connect, or select the adapter that you want to have for that VMware iSCSI LAN, and that's it. So once you select that, hit next. So if you already have a LAN created, you can uncheck this box, but if you don't, you can check this box. In that sense, you can create the VM together with when creating the initiator as well. So here, as Daniel showed already, I'm not going to go through that process, but if you do plan to use it for Hyper-V, you can choose 64 for VMware, choose 32K, and so on and so forth. So once you create that iSCSI LAN, this is the setup. So as I mentioned, so each VM, so in this scenario, you will have one VM, one initiator for VM1, one initiator VM2, and then have its own iSCSI LAN. So instead of the single 5 terabyte LAN I was talking about in the previous example, you can just create one LAN with 1 terabyte. And then on here, you can just go to, so this is just a basic VMware setup that we have. I'm not gonna be staying a lot in VMware, because again, I understand a lot of different versions and different versions that you might be using. So I'm just giving you a basic example here. Under storage and adapters, you can click on the software iSCSI, and then you can click on add the static target, and then just copy that. Just copy the initiator. Modify. Just copy that here. So let me create an iSCSI LAN there as well, so just you can see here. It's a very simple 20 gig LAN. This is just an example here. And we're gonna map that to that iSCSI VM. So let's say I'm gonna give the new VM a 20 gig LAN, so I can just click that, enter the IP, and then enter the IP address of that QNAP NAS, just 10.15.140.78, and then click on save. I think that I added the right one if I'm not sure, but once it finishes, I think it's still scanning. So once it finishes scanning, the devices will show up that new LAN, which is a 20 gig LAN. So this way, each VM will have its own separate I2C LAN. Right here, the 20 gig LAN has showed up. So now we can just create a new data store for VMware VM1. Select and then you can partition that according to your requirements and hit finish. The data will be deleted, so you just have to be careful that no data in that LAN and hit next. Now it should show up here shortly. The 20 gig LAN right here. And now when I create a new VM, just an example of a VM that I want to create. Or just keep it simple. I can select that new LAN that I created, and I can section it out the hard drive disk space I needed to. So this way you can do that as well. Or the another scenario is if in case if you have a hybrid QNAP where you have a large SSD LAN and then you also have a hard drive. So you can actually create your operating system or the hard drive disk one. So you can section out multiple I2C LANs from the SSD volume. So you can have a LAN from the SSD volume of the QNAP and then a second LAN from the hard drive volume where you can have a lot of data in there. So the operating system for that VMware will run faster because it's stored on the SSD part of the QNAP, whereas the hard drive is just for storage for data, right? So you can actually have multiple hard drives, one from the SSD volume, the rest of them will be from the hard drive. So in the Windows VM, you will see local disk C and local disk D. So that's also another option as well that you can actually do with the QNAP as well. So that's how simple it is to create an I2C LAN within the QNAP. As well as just adding that as a data store within the VMware as well. Another thing that we recommend is in case if you have a direct connection from the QNAP NAS to the VMware, we recommend having a higher MTU as well. That's also gives you better performance. Also has less overhead on networking part as well. So if you go to QNAP, go to control panel. So in here in the 10G part of it, you can just click on configure and have a jumbo frame as this especially only for like 10G and above. If you have a single 1G connection or 2.5G connection, this probably won't be recommended. But for 10G connection and above, we recommend having a higher MTU, about 9,000. So once you set that up on the QNAP, now before you set your MTUs, you have to ensure that your VMware setup has MTUs available. So because MTU, if there's a mismatch on your networking, anywhere between your networking, between the QNAP storage to your VMware, there will always be, some weird issues of disconnection, data corruption, or could be some weird issues that you may have. So you have to ensure that the MTU is standard across the networking, where you're setting up. So if your hard drive, if your data store, which is connected directly to the QNAP, if it's just directly connected, you have to ensure that enable on the jumbo frame on the QNAP and enable that on the VMware side. And since there's nothing in between, that's okay. Now, if you introduce a switch or a router or anything in between, then you gotta also set up MTU as well. QNAP switches have the unmanaged switches have automatic detection, so it will detect it's 9,000 MTU and you're fine. If you have a managed QNAP switch, you can set up that on that, or actually it's also auto detection on that managed switch as well. So you just have to enable that, or you have to even enable that on a QNAP switch. But if you don't have a QNAP switch, you have to enable that on other switches as well, ensuring that it's all set up correctly. And then on the VMware side, you just have to go to so on the networking, on the networking part, I got confused. So yeah, on the networking part, on the virtual switches, you gotta ensure that you also set up the MTUs as 9,000 as well on the MTU on the VMware side as well. So that completes the setup on the QNAP as well as on the VMware side, and that's it. And that's recommended as well for better performance as well. I think that the
Oh yeah, it's probably good by now. Yeah, should I share my screen?
Yeah. So we're gonna continue with showing how to set up cache acceleration as well.
So first of all, I'll go here, and there's a pool. So want to make an iSCSI LUN. You can set up cache for either LUNs or share folders. But since this is for VMware, let's make a LUN on this particular NAS. Let's just make a new LUN.
You just make a target on LUN.
VMT. And so, yeah, thin provisioning. So I think this size should be fine. And so now I'll go back to, so now you can see I have the LUN, it's mapped to a target. And now I'm going to go to storage and snapshot to enable cache. So again, I do not recommend SSD cache for SSD storage, but I still want to show you how it is set up. So I have two SSDs here. You see here, most of it is going to be read cache, and then just 10 gigabytes for a ZIL write log. And that's because the way ZIL works, it's not standard write cache. We're doing the write coalescing. We take many small writes, pull them in the RAM, coalesce them in the RAM, write them to the drives. The ZIL just needs to hold what's in the RAM so that if the NAS loses power, what's in the RAM can be restored from the ZIL. So data is not held in the RAM very long. I think at most we're going to hold this data in the RAM for like 10 seconds because way write coalescing works, you just hold in the RAM a little bit to coalesce it, write to the drives, and hold more in the RAM, coalesce it, write to the drives. We should be writing to the drives at least every 10 seconds. So the ZIL needs to hold at least 10 seconds of writes. So as you see, it's just allocating 10 gigabytes. So I'm not going to apply it to my share folder. I mean, I probably shouldn't apply it to anything because it's SSD storage, but here's how you would do it.
No, this was just as an example of showing you how, like, in case if you do use it for SSD as well. If you go back, now if you do have multiple VMware LUNs inside your QNAP, and not all of them are that important, QNAP does allow you to go back. Select the cache for the first option. So QNAP allows you to select which LUN do you want to really cache. So not all VMs are equal, right? Not all VMs need the fastest performance. Some VMs are just maybe DHCP servers, DNS servers, those small VMs that are not that important, may not require to have any kind of caching. Just sit there and just those are fine with the basic performance. But some VMs, if you're running some database applications or some VMs that are intensive or resource intensive application, so you can select here which VM. The QNAP will only concentrate on those VMs to be able to enhance performance. So we're just showing you the cache setup in case if you do use hybrid setup, right? If you have a QNAP NAS with SSDs or M.2s, and then you have a hard drive for storing your high data store. So with the advantage of having M.2 or SSD drives, you can take the advantage of having cache acceleration with those.
So to go next, you can do random IO or all IO. Vast majority of the time, I suggest random I/O. Like if you have a unit with 12 drives, 16 drives, 24 drives, the sequential throughput of 24 drives is generally pretty good because you're not limited by the throughput of one drive. And so SSD cache is likely not going to improve on the throughput on our larger units, but hard drives have much less IOPS than SSDs. So SSD cache can very likely improve on the IOPS, and for VMware, IOPS is normally the number one concern. So random I/O is what I would almost always suggest in like the vast majority of cases. And so I think this is neat here. So we have the read cache. See how it's set in RAID 0. So I have two SSDs, RAID 0 read cache, and that's because read cache is actually a pretty safe cache. If you were to lose the cache, you don't lose your data. The data is all in the drives. But so it's a pretty safe cache, so RAID 0. But notice the ZIL is in RAID 1. So this is kind of like hybrid RAID. We don't normally support a lot of hybrid RAIDs, but you can think of this kind of like a hybrid RAID. A small portion, 10 gigabytes of this SSD is put in RAID 1, and the vast majority of each SSD is put in RAID 0. And because with ZIL, you don't want to lose that data because if the NAS has a power outage, you want to be able to restore what was lost in the RAM. You want to restore it from the ZIL. And if you fail to restore it from the ZIL, that could endanger your data. So we put ZIL in RAID 1, but the read cache can be in RAID 0. And I'm not going to click create because, again, we don't suggest SSD cache for SSD storage pools.
So we'll hold here for about a few minutes of Q&A session, and then from there, we'll continue from here.
On QTS, a broken or removed read cache is putting the cache volume in error state through QNAP. QNAP support can fix it via help desk. So yes, QTS cache is different. So QTS cache does have higher risk than QUTS Hero cache. So I'm showing Hero NAS. So QTS has standard write cache, which I mentioned earlier has more risk. And even the read cache, if you lose the read cache in QTS, it still can it can still mess up your storage, but there's a good chance of tech support being able to help on QTS. On QUTS Hero, losing your read cache has much lower risk. On QUTS Hero, the read cache is not even designed to be persistent through power cycles. It's a pretty safe cache. And then for the ZIL, the only time you really need the ZIL is if you lose power, because the purpose of ZIL is to restore what you lost from your RAM. So for a lot of use cases, if you lose what's in your RAM, like if you're sending a file and you lose power, you just send the file again. So it's not a big deal that you lost what's in your RAM, but there are certain applications, particularly where we're not file aware, where if you lose what's in your RAM, the NAS may not be aware of what's not yet written to the drives. And sometimes in iSCSI, in like VMware, we may not be file aware. The QNAP may not be file aware of that iSCSI storage because the QNAP is not managing that iSCSI storage. VMware server is. So since we're not file aware, it's more important that we not lose what's in that RAM. And so what the ZIL is there for is to, if we lose what's in the RAM, we restore it from the ZIL. So the ZIL, it's not too dangerous because it's only the rare cases where you need to restore what's lost in the RAM from a power outage, and the ZIL is then kept in RAID 1. And even in that scenario, the times that would most likely endanger your data is when we're not file aware. So ZIL is considered a pretty safe way of doing write cache, and the read cache, you could just lose the read cache and nothing particularly bad happens except that your performance would be a little bit less if you lost your read cache in Hero. But yeah, QTS is a different story. And on QTS, I'm going to say right now, don't use write cache with VMware on QTS. As a blanket statement, I am going to suggest don't use write cache on QTS with VMware, but Hero ZIL is much safer.
So another part is that QTS platform, the cache is a different mechanism inside the operating system that was developed by QNAP to be able to provide that cache acceleration. But with QTS Hero, we use the native cache acceleration mechanisms available within the ZFS platform. That's what we're actually using for for cache acceleration. So it's better performance. It's actually more stable as well, because since we're using the ZFS's native application to be able to do the cache acceleration. So a few more questions.
Which drive do you recommend? Oh, I'm skipping one. Let's see. What type of device is recommended for cache? Well, you would use SSDs to cache. So you have HDD storage, but SSD cache. And what kind of SSD do you suggest for cache? Well, the faster the SSD, the better. So if you can use NVMe SSDs for the cache, I suggest NVMe. And another thing is if you're trying to accelerate synchronous writes, so if you map NFS on the VMware, the writes should be synchronous by default. On iSCSI, it's a mix of synchronous and asynchronous. So if you want to increase your synchronous write speed using ZIL, choosing SSDs with power loss protection makes the ZIL faster. And not everyone understands this, but the way ZIL works, the way synchronous writes works is you write a block of data to the NAS. You are not allowed to start the second write till the first write gets on persistent storage. If the SSD has power loss protection, the SSD's DRAM cache, the DRAM cache on the SSD can be considered as persistent storage if the SSD has power loss protection. That's because if the NAS were to lose power, the data on the SSD's DRAM cache will persist. That's what power loss protection is there for, so that the data on the DRAM cache, on the SSD DRAM cache will persist even with power loss. So if you have ZIL with SSD's power loss protection, then you just wait for the block of data to be written to the DRAM cache on the SSD, then you start the next write, so it makes the writes faster. If the SSD does not have power loss protection, you wait for it to be written to the SSD's DRAM cache, and then wait again for it to be written from DRAM cache to NAND flash. And that means each block of data has to wait longer for the write. And for an idea of how much performance difference this can make, Serve the Home did a test I think like a year ago or so, and they actually found that a SATA SSD with power loss protection could outperform an NVMe SSD for the ZIL. I mean, if the NVMe SSD had no power loss protection, basically SATA SSD with power loss protection outperformed the NVMe without power loss protection for ZIL, because basically, even though the SATA protocol has higher latency, it was still able to write to the SATA DRAM cache faster than it could write to the NVMe NAND flash. So basically, NVMe is faster than SATA, but NVMe with power loss protection will be your fastest ZIL. And then without power loss protection won't be as fast as with power loss protection for ZIL, if you're specifically using it for ZIL.
There's another question.
Which type of drive do you recommend?
Okay, we discussed that. Yeah. So keep running any questions you guys have as well. And then also, if you guys want to unmute yourself, you can always have a conversation as well. If you have a mic and a speaker, you can always, feel free to unmute yourself and ask further questions. So we'll wait about a few more minutes. I know so the good part is we're running a little bit early, so we can get this workshop wrapped up earlier than scheduled time. So, but we're always happy to answer any questions you guys have. So, please feel free to post any further questions you guys have. All right, so we're back. We can get this next part started. So, part 3 for the workshop.
Yeah, so part 3 is using a snapshot replica, snapshot agent, using SnapSync.
You can full screen it so they can look better.
Yeah. So basically, we have various replication features. So a snapshot can take local snapshots, folders, or LUNs, but snapshot replica can replicate a folder or a LUN to another pool or another NAS. And it's a great way to have a way to restore your data. We'll talk about the difference between application consistent snapshots and just crash consistent snapshots, but we have a snapshot agent can help make your snapshots application consistent. SnapSync is similar to snapshot, but it's a real-time sync. So yeah, let's get into how to set this up. Well, actually, let's talk about the differences first. So snapshot replica with snapshot agent. What should be understood about snapshots is they take a snapshot of the data that's on the drives. So let's say you have a VM running in VMware. There's data that's on the drives in the LUN, but there's data in the VMware server's RAM, right? Same with your computer. My laptop has data that's on my drive, but there's data that's on my RAM. Snapshots take a snapshot of the data in the RAM, so in the drives, so I can later restore the data in the drives. If I were to take a snapshot right now of the drives, but anything that's in the RAM and not on the drives would not be restorable. So a crash consistent snapshot that saves the data in the drives, but you'll probably have to reload the applications. Whatever is in the RAM is lost. And in some cases, that's a big deal. In some cases, it may not be a big deal, but it won't say what's in the RAM. An application consistent snapshot saves the current state, even what's in the RAM. And the way that we can do that is our snapshot agent. Snapshot agent can run on a Windows machine. So here, let's go and open this up. This just download to your Windows PC. You'd have it towards the bottom. Snapshot agent. And so basically, you would download it not on your PC, but I would just say on your VMware, Windows VM. It runs on your VM. And so then when your NAS is about to take a snapshot, it talks to snapshot agent and says, I'm about to take a snapshot. Snapshot agent talks to Windows and says, we're about to take a snapshot. Everything that's in your RAM, write it to the drives right now. And then it takes the snapshot, and therefore everything that was in your RAM was included in the snapshot. So therefore you can restore everything that's in your RAM as well when you restore from snapshot. And so it's very easy to download. You just log into your Windows VM, go to our website, and download the snapshot agent. So talk about the difference between snapshot replica then and snap sync. Snap sync is a real-time sync. Now, because it's real-time, it's not going to be application consistent, right? We can't tell the VM we're about to take a snapshot, take everything in the RAM, write it to the drive, so we're about to take a snapshot, because snap sync is real time. It's always syncing all the time. And so you can't always have everything that's on the RAM be in the drive. So snap sync is not application consistent, but it does in real time sync everything that's on your drives to another NAS or another place. And so that is great for restoring all your data that's on the drives, and it's a real-time sync. So it's the most up-to-date, it's most up-to-date sync. So let me go on the NAS right now. And I think now would be a good time to do a snap sync. So I've already made a LUN. And so now I can make a snap sync or snapshot replica job of the LUN. Let's do snapshot replica. So let's replicate the LUN. Also could just put the IP address.
We have a question about immutable backups. Any solutions available for immutable backups?
But maybe should we answer that now, or should I?
Oh, just finish it. IP.
I'll do IP address and enter the IP.
Get or remove the HTTP.
Yeah.
SSH port, so we need to enable. So that's another guy. So SSH needs to be enabled if you want to use the snapshot features of the QNAP.
Right.
So I'll enable SSH.
I can do it. Yeah.
Yeah, already enabled. We can go back.
It's already enabled. Okay. Let's try this again. Okay, so we're good there. And choose the destination pool, but there's only one pool, so next. So I can take a snapshot replica on a schedule or take a snapshot replica. So take a new snapshot on a schedule and then run a replication job.
So you can either have a different schedule for snapshots. It will take multiple snapshots saved on the local NAS and then do a replication job of that snapshots into the QNAP. Or you can just set up a snapshot replication job and then QNAP will take a new snapshot every time the job is about to run. So before the job runs, the QNAP will take a snapshot of that iSCSI LUN and then it will replicate that snapshot that you have just the software just took into the second QNAP.
And so I tend to like this option here, start a replication job after taking a local snapshot, though I better set up local snapshots on the LUN. But I think this often makes the most sense. When you take a local snapshot of your LUN, it takes a replication of the LUN. And so let's see if it lets me do this. And now I'm going to go and actually set up a snapshot for this LUN. Snapshot manager. So let's say hourly. I would choose application consistent, but I actually have not yet put snapshot agent on the VM. So I can't really make it application consistent until I put snapshot agent on the VM. So right now I'm going to say crash consistent. Your snapshot. Let's see. To snapshot replica. So right now it is replicating this to the other NAS. And we should soon see it show up in the 574. I probably shouldn't mess with it while it's running, but I won't change anything, but you can edit some things here. Success. So now let's go over here. So we have it here. So, I mean, that was the main, well, maybe I'll show a snap sync job as well, since I think we have plenty of time. So on the destination server, you're going to want to have snap sync enabled, but it should be enabled already. So let's go to snap sync. Create a snap sync job. Sync to remote. You can also kind of pull it from remote, but most of the time I think you're going to sync it to remote. So choose the LUN you want to snap sync. It automatically gives it a name, but you can change the name if you want. So you could do detect, or you could also just do the IP address. I like real time for snap sync. And let's give it a destination and names. Let's call it snap on.
And then here you can select, maybe because since the QNAP provides you with multiple network ports, maybe you can have the VMware Datastore running on that first 10G port, and you can use the snapshot replication onto another 10G port. So you can keep the data and the performance, networking performance separate. You don't have to share the same pipeline across to be able to do snap syncs or snapshots. So you can select which which networking that you want to use to be able to do all these backup jobs onto the QNAP.
And so you can adjust the latency threshold, but I'm just going to keep it default.
Oh, you didn't do a backup to which device right now? That's okay. That's the process we wanted to show, because I think because it's running a snapshot job as well. It's because we're running multiple jobs, so I think that might fail. That might have created the issue. But that's the way you set up the jobs on to the QNAP. That's the snap sync job. So I think we have a few questions that we can go to first.
Is there any solution available for immutable backups? I mean, we support Veeam immutable backups if you want to use Veeam. And there is, of course, other third-party software. So we do have our own software for backups, though I don't think our own software be immutable. But I think Veeam immutable backups is a good way. If you have a QUTS Hero unit, you can make a worm folder, use our QU Objects app to make the QNAP as S3 compatible storage. And if your S3 compatible storage is on a worm folder, worm is an immutable folder, then you could do Veeam immutable backups. It's a great way to, it can back up, it can even have versioning on immutable backups. And of course, you can always make immutable folders, but that may not be as useful in VMware. So Veeam immutable backups is likely the best option.
Yeah, so unfortunately, right now QNAP doesn't have any immutable backups for VMware solution available, but we do support third-party backup software, as Daniel mentioned, like Veeam, to be able to do an immutable backup. There's one other question we have.
Is the Snapchat agent also available for Linux VMs? I don't.
Yeah, right now it's only available for Windows, unfortunately. It's not available for Linux, but I can put in that request to see if there's any work in any pipeline that we have for Linux-based systems, basically. All right, so I think that is it for the part 3. So we're gonna move on to the last part of the session that's focused more on our new license-free backup applications for Hyper-V and VMware. So let me share my screen quickly. All right, so, sorry, that's the wrong screen. All right, so the last part about our workshop, we're going to focus more on Hyper Data Protector application. This is an application available to back up your VMs onto the QNAP without paying any kind of licensing fee. Now, if you're running like a small business or home labs, paying like a backup fee for backing up your VMs can cost a little higher, especially like third-party softwares. You have to pay a hefty licensing fee to be able to do a backup job. But if you already have a QNAP device that's already hosting your VMware data store, you can section out a small folder out of that QNAP storage to be able to do backups of that VMs, or you can just purchase a small QNAP to be able to handle your backups as well. And the application is called Hyper Data Protector, so you can go to your QNAP NAS, visit App Center, and just look for Hyper Data Protector using the App Center. It's a free application. There's no licensing required for that application. And you can, once installed, click on open and open this application. So again, we support right now VMware, Hyper-V, as well as Windows and PC server backups. So now the new feature for this application is it can now support your image backups for your Windows and PCs and servers. So if you want to take image level backups of your computers, this will be able to do that as well. Just install the application. Just install the application on your QNAP NAS and install and download the application for your Windows computer, and you can now do image level backups. So in case if you lose your complete computer, you can just restore that image to another computer, or if you want to go back in time and restore, because it does support versioning, so you can recover from a different version of that image, or you can actually recover some files within that particular computer. So that's another new feature that it's available, again, license-free application for that as well. Now, we're going to focus more on VMware setup. So first we need to enable, as I mentioned, you need to section out some part of the shared folder within to be able to accept the backups from the QNAP. So you got to create a folder. I'll just create like a random folder, HDB backups. And then you can just select which disk volume it's supposed to be on, hit next, and then that's it. Just hit next to create the folder. That's very simple on that. Once you create the folder, you gotta first be able to add the repository. So you create a repository. Now, if you're moving this Hyper Data Protector to a different device, you can relink it so all your backups come back, but you can create a new repository, choose the folder that you just created. Okay, so we just created this backup and just select that. Now, if you're running multiple different applications, like you're running VMware, you're also running Hyper-V, you're also running your own, you have multiple Windows computer, you can create separate folders for all of that. So you can keep all the repositories separately. So VMware will have its own. So I have a repository already created. So I'm gonna go back. I'm sorry, should have showed you how to create the folder. So So we're gonna select, let's say, new folder, hit select, hit add. This will add that into that repository. I already have a repository created called VMware Backup that's hosting my backups for all the VMs from the VMware that I have connected right now. So once you have done that, you can see once it's created, it does show you some information about how much space it's using, also the deduplication data rate. So this application does support deduplication for VMware Hyper-V. So because virtualization, as we all know, has a lot of duplicated data, especially if you're running a lot of Windows VMs or same type of VMs running with the same operating system, there's a lot of shared data within all the VMs and virtualization. Again, virtualization has highest number of duplicated blocks that we have seen. So with deduplication, you can actually save a lot of space within the QNAP to be able to host all the backups. So in that case, you can see right here in the background, it does show deduplication as 57%. So at that point, it's running the 57. It's actually 57% of space that is being saving on the QNAP. The reason that it's right now it's a little bit slower is because I'm running this QNAP for hosting my Hyper Data Protector. It's also running some some surveillance application. I'm just using this as a backup. So just don't mind. It'll be faster because this is a demo dance. I'm running a lot of different demos within that QNAP. So forget about this. Once it's created, you can see that how much space it's been using. I think it's also running a backup job as well. So right now I'm running a backup job, but let me create a new backup job so I can show you how to create a new backup job. So the source will be your VMware, or if you have Hyper-V, if you have Windows computer. So VMware next. Now it will show you all your vCenters and as well as the VMs that are running. So you can select the whole vCenter as well as if you want to just back up certain amount of VMs. So you don't if not all your VMs are important, you can select just certain amount of VMs that you want. And then once you've selected the number of VMs you want to back up, hit select, and now where the backup destination would be. So you can click on that backup repository or one that we just created, hit select, hit next, and you can schedule this to be able to do like hourly, daily, weekly, monthly. So because of this, you will have different versions of that VM. So you can restore a certain amount of certain number of or certain version of the VM. So if you do like daily backups, you will have one version per day, and so now you can restore a VM per last week or a week before that. You can also do monthly as well. So you can have monthly VM versions as well, or you can do weekly and then select which day of the week is important. Like during weekends, it's not running, so maybe do a backup during that time. So you can split resources as well. During the weekday, maybe the office is online, so there's a lot of processes that's happening. So you don't want to run or block down your processor or run some backup jobs during the week. You can do it during the weekend as well. You can select the time as well. So I'm just going to cancel the schedule right now. And if you do have multiple backup jobs, you can select, I want to run the backup job. So maybe you have a multiple setup like VMware setup, or you can have VMware with about 20 VMs and you have a backup job of like first 5 VMs. You're splitting your backup jobs in multiple different jobs. You can say run that first job, after that run the second job, after that, so on and so forth. So you can do that as well. We'll just keep it no schedule. Hit next. You can do transfer encryption, compression, and the VMware CBD for all. So the CBD, we also support that feature as well. And I think you have to enable that on VMware, but right now, you can enable that and it supports that as well. We also do application aware processing, so you can when it runs a backup job, it does application aware or based off Microsoft VS, it supports that as well. Hit next. Once you have done all of that configuration, it'll give you basically a summary of what you have set up, and then you can start the create job, or you can start a backup job. It'll create and it'll start that backup job immediately. So going back here, it will show you how many backup jobs you have successfully run. If there's any errors, I'm just running this as a started that yesterday. Deduplication rate, how much space it's been using. Now that's creating a backup job. Now let's see if you have a disaster issue and you want to restore a certain VMs within that from the QNAP. Now it's very simple. Again, with QNAP, the best part is that the learning curve is pretty less. So you just have to start to create to restore something. You gotta go to restore page and click on job, create job, select source. Now this would be the QNAP that you'll be. So where you wanna restore this to. So hit next. That will be your VMware. You want to restore this back to your VMware. Now, because I have 2 versions right now, 2 days of versioning, I can select which version I want to restore that to and which VMs do you have already. So for yesterday, I have all the VMs, but for today, since it's still running the backup job, I only have certain VMs available. And then so you can select, let's say I want to restore the Active Directory VM from yesterday. I can select that VM, hit next. Hit next, like 80 restore, or it's just up to you, whatever you want to name. Hit next. Usually there's no schedule. You're not going to schedule your restore. Right? Restore is only disaster recovery, right? Something major that's happened within the VMware, and now you want to restore that. So you select no schedule, hit next, And then the best part is you have two options. Now you can override the VM. Since the VM is already running, but it's corrupted, you can ask the QNAP to override the VM. So you'll delete or destroy the old VM and just override with the restored data, or you can rename it. So it will have two copies of the VM. If you have space on the VMware, you'll have two copies, right? The original copy as well as the renamed version of that VM. So now you can compare data between both of them. So if the VM is still running, you just want to compare within that VM, there's some corrupted data, or there's some issues within the VM that you want to compare the old data from the new data. You can restore that and just copy that small section from that with restored VM into the original VM. So the original VM is still running and everything is running fine. And you don't have to do it and reconfigure anything within the new VM. You just copy the corrupted data back into the new old VM, and the old VM is still running. So you can do that as well if you wanted to. And then, or you just override, destroy the old VM completely. Once you have done that, click on restore, and it will start restoring that VM into the VMware, and simple as that. So again, this is all this feature that I've shown you is license-free application. You don't have to pay any kind of licensing fee to QNAP. We just have to have a QNAP hardware, go to the App Center, and then do the backup jobs into the QNAP using the Hyper Data Protector application. A few other things that I want to show you. We have a landing page that talks about virtualization, but again, we are certified for VMware, Hyper-V, Citrix, Veeams as well. So we are certified for all that as well. So if you want to if you want to use QNAP, we are certified hardware providers for VMware or for virtualization environment. We do support ISO-Z, NFS, also Fiber Channel as well, if you want to do that as well. We also support all of that protocols. Again, RAID protection for data protection, or RAID as well for data protection. VMware, vSphere, Hyper-V, Citrix Zen Server, all of this is supported. We have plugins for Kubernetes if you wanted to install that as well. We also support ISER. So if you want to, we have many cards that do support ISER. So that will reduce the overhead on the CPU to be able to give you better performance over the networking of that QNAP. So especially for all-flash NAS array storage, ISER can really help boost performance, and we do support that on many of our networking cards as well. And then for virtualization, for ISO-Z, we do support VAAI for full copy, block zeroing, all of that features are supported as well. We support Microsoft ODX as well, or offload data transfer. Allows you to be able to offload a lot of information instead of using the processing power of the QNAP. And then for management tool, we have our QNAP vSphere client plugin to be able to create ISO-Z Datastore, all of that within using that QNAP plugin. So we do support all of that as well. And this page can also show you which NAS are certified for which application. So you can select a certain NAS that you wanted to, and then see what are they certified for. So you can check certification statuses here as well.
And I'd like to add that we don't certify every NAS, but I mean, if there's a certified NAS, another NAS running the same operating system, it should work just fine. Our NAS work well with VMware. Our NAS work well with Hyper-V. We certify a good portion of our NAS, but a lot of but for uncertified NAS, as long as they're good performance, is fine. So, if you have an ARM processor NAS, it should work, but the performance will be low. You have like Intel, AMD NAS, performance should be higher, but the point is certified or not certified, it should work. But of course, a lot of people do prefer the certification, and we know that, and that's why we did certify a good number of our NAS.
All right, anything that you want to add?
I think I'm good for now, but we do have another question. Hyperdata Protector setup. Can you connect to vCenter directly, or have you to add individual physical hypervisors and set up the backup jobs on each VMware hypervisor?
Let me confirm. I think we have a list. Right now, I think the support is 6.5, 6. I have to confirm on that. I'm gonna post my email address on that chat. So can you send me an email and I can respond personally to you with more information once I have it.